In a distributed ecosystem that emerged as the market evolved, and both system operators and their users developed a better understanding of how things should work gradually, it is common to see that the distributed ecosystem emerges without a reference architecture pre-agreed by all in the market. We can see this happening, for example, in modern online gaming, where many architectures have been tried. After many years of learning, a certain domain knowledge began to emerge. We present here a domain decomposition approach where the architecture of the ecosystem emerged gradually. The emerging structure does not seem impressive. This is by design. To accommodate the many genres of online games, this emerging structure needs to include only high-level abstractions. The structure here has 4 pillars: the virtual world, labels 1A and 1B, gaming analytics, label 2, procedural content generation, label 3, and a social metagaming platform, label 4. Each is very different from the other, so each is built on both general and specialized distributed systems technology that is specific for that part. Some of the many distributed systems techniques used in this ecosystem are specialized naming and communication, specialized consistency protocols, for example, the Diconit's continuous consistency protocol, engineering the complex trade-off between performance, availability, cost, and many other non-functionals, resource management and scheduling based on cluster and multi-cluster approaches, both short-term and long-term, with many specialized techniques, big data processing, including graph processing and specialized gaming analytics, and processing various kinds of workflows, both compute and data intensive. The virtual world pillar manages the virtual world of the game. Often, gamers assume this is the entirety of an online game. Essentially, the virtual world is often a complex simulator akin to an n-body simulation in physics or a model of the city's transportation system, building an efficient platform for massive scalability subject to the tight and very specific service level agreements imposed by players, while keeping the platform cost-effective and, this is more recent, sustainable, is an important and really complex challenge. The virtual world connects directly to the players, and some players do not have enough resources to simulate and render the virtual world content. For these players, but also for other reasons, game operators may instead develop a game streaming approach, where the game is rendered on the machines of the game operator, and the resulting video feed is streamed over the internet to the users. It remains very challenging to manage the rendering farms while offsetting the internet lag and performance variability. All of this subject to cost effectiveness and sustainable operation needs. Gaming analytics are important for every modern online game, from providing actionable insight into the operation of the platform and the game, to nearly automated community management and toxicity prevention. Analytics are also useful for rating and ranking players and for forming matches between them. Cheaters and abusive players can be detected before they can damage the game or its community. Often unbeknownst to players, many stakeholders can partake in gaming analytics. Gaming operators, the game development team, data scientists part of a larger customer engagement team, external partners, and especially advertisers, and many others. The content generation pillar includes techniques to automatically generate and then distribute new game content. Producing and distributing content for 1 billion players, large platforms have already reached over 250 million monthly active users, remains an important challenge for online gaming. Last but equally important, the social metagaming platform allows players to form communities. According to Dr. Richard Garfield, when you play a number of games, not as ends unto themselves, but as parts of a larger game, you are participating in a meta game. For example, this relates to playing in a tournament where strategizing where to spend more effort and more resources becomes important beyond the confines of one game. But metagaming can also include gaming-related activities that are not gaming per se, such as building new content for others to enjoy, commenting on the performance of a player, spectating online games, and many others. Supporting these diverse and complex activities and providing opportunities for more spontaneous and emergent community behavior is truly challenging. Online games that can manage the 4 technology pillars have a good chance to succeed in this business. Good game content is still needed, but without technical capabilities, players often just quit the game and move on to another game in a similar genre.